So we have to define our space. So something's being dropped. We don't know how high it is. And because I don't know how high it is, I'm just going to call y0 here equals to 0 meters, v0, and we'll just assume it's v0y because it's one dimension, equals 0 meters per second. And we should use, we have to watch our sig figs. So we got to look at what they give us. So I mean, it's usually safe to assume 3 sig figs. Okay. Then acceleration is going to equal plus, and we have to use 9.80 if we're doing mastering. Okay. And we're going to say that the plus direction now, it's already implied there, is that plus direction is down. So by reading the conditions, they say that at some time later, t0 equals 0 seconds. At some time later, and at a height of y1, which we don't know, and at t1, which we also don't know, and we don't know v1, don't know a lot, but what they're saying is, though, there's also another time, t2, which equals t1 plus 1 second. So now we have a y2 equals, we don't know. Now I may not have allowed enough room for the bottom, wherever it hits. So I'm just looking at part A for now, but I get the feeling is once you start seeing this, you'll start seeing how it goes. So, and we don't know the speed there, but we know the delta y, and which is equal to, delta is always where did you end up minus where did you start, and it's equal to 49 meters, and it's a plus 49 meters because we're saying that positive direction is down. So when we get to the ground is going to be some positive number. And what else do we know? Well, we know the difference in time. So for discussing this interval here, remember we have this equation y, so y, this one here, the first one is y at some time equals, and if you like, which would be the final position, y sub 0 is also the initial position, plus v sub 0, which is also could be thought of as the initial position, times some time, which remember is a delta t. It's always some delta t. A lot of times, though, we choose the initial point to be 0, so we don't usually think of it as a delta t, but it is a time interval, plus 1/2 a t squared. So if we adapt that to our what we're thinking of right here, that means that y2 equals y1 plus v1 times t21, which is our delta t, which is 1 second. So I'm dropping the delta, plus 1/2 a t21 squared. And then we can rearrange this. So let's see, I think I see a mistake in my, no, I don't. So we leave the v1 on this side. So we move y2 minus y1. We'll put parentheses around that because we kind of recognize that, right? minus 1/2. Yeah, I might have goofed on that. No, I didn't. I put the minus sign in there, didn't I? Let me see. Yes, I did. Okay, half a t21 squared equals v1 t21. So at the end of the day, it's my delta y minus 1/2 a t21 squared over t21. Now, what the question asked, so now we need another place, T3, which is equal to T2 plus 1, or it's equal to T1 plus 2. We don't know. I mean, we don't know its exact value, but we know its relative value. Excuse me. So this is Y3. We don't know what it is. Oops. V3, we don't know what it is. But we're asked, what is delta y equal to? But we do know V1. So we could calculate what V2 is. Let me think. Is there another? I'm just wondering if there's another way to do this. Could we start up here? And so, yeah, I guess it gets complicated. So what we can do is, let's see, I should have made a duplicate. Yeah, let me think about this for a minute. Let's duplicate this. And then, so we already calculated what V1 is. I don't know why my computer's been acting funky lately. Okay, so we know what V1 is now. And I forgot what we got, but let's see. 44.1 meters per second. So our new equation we want to get this delta y would be y3 equals y2 plus v2 t 32, excuse me, plus 1/2 a t 32 squared. So that happens to be delta t 32. And we know that's 1 second. So this one's easy because, and also don't forget that delta y is equal to y3 minus y2. So if we simply bring this one over here, t32 plus 1/2 a t32 squared. Now the problem is that we don't know V2, but we can get V2 from the other magic equation that says that V equals V sub 0 plus AT. So we think of this as the final, this is the initial, and we know the rest. So that says to me that V2, that's the final, equals V1 plus 1/2 a t32 squared. And then we can calculate V2 and remember to use 9.8. And then we could put it back into this guy here. And then you should be, and then you'll, if you use the, and it looks like 3 sig figs, carry that through, double check what they give you, how many sig figs are in what they give you. Because I can't, mastering physics, it gets picky on sig figs, and you just have to use 9.8 meters per second squared. For me on a test, 10.0 meters per second squared is fine. But I can't tell mastering to accept fuzzy answers like plus or minus 10% answers. I've even been on with tech support and they don't know what to do. So why don't you give that a try and then come back and get back to me?